Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone, welcome back to the tutorials on natural language processing. In the last classes we saw about bag of words approach, and we saw how bag of words approach helped us to convert a text into a vector, and like that was the pre-processing part, and afterwards how we could actually apply machine learning algorithms. So we have seen the bag of word approach. There is one more approach for converting text into a vector form, which is also known as TF-IDF approach. TF-IDF approach. So TF stands for term frequency and IDF stands for inverse document frequency. So a multiplication of term frequency star inverse document frequency or multiplied by inverse document frequency is the complete approach. Hence the approach is also known as TF-IDF approach. Right. So as you already know that a machine learning model only works on numericals. It cannot work on text form. So what we do, we actually convert the text into numbers so that we could actually like apply some of the machine learning algorithms so as to get the predictions or so as to get the results. Right. So this is what we are used to doing. So far so good. We have seen the bag of words approach where we had a look like how we converted that like text into numerical format. Like if the text was present, we actually assigned it to 1, and I mean if the word was actually present, we actually assigned it to 1, and if the word was not present, we assigned it 0. All cool till here. So now let's come to our new approach, which is also known as the TF-IDF approach. So let's say I have 3 sentences, sentence 1, sentence 2 and sentence 3, and the 3 sentences are play cricket, play football, play cricket, football, tennis. So if you see if you see these 3 sentences, you will understand that these 3 sentences have actually come after tokenization, lemmatization and stopwords removal. So maybe I had a very large sentence, like some of the words, like more words were there, but then I actually did my pre-processing, the 3 building blocks of pre-processing, tokenization, lemmatization and stopwords removal, and this is the final result that I have got. So I have 3 sentences: play cricket, play football, play cricket, football, tennis. And now what I want to do is that I want to actually convert these 3 sentences into vectors, that is into numerical forms, but this time using TF-IDF approach. Right. So you have the formula for TF and you have a separate formula for IDF. So the formula for TF is number of repetitions of words in a sentence divided by total number of words in a sentence. A very easy English form, very easy formula written in English. You could actually look over here, TF is number of repetitions of the words in a sentence divided by number of words in a sentence. And similarly, the formula for IDF is log of total number of sentences upon number of sentences containing the word. Don't worry about this. I will actually explain you how it's done and how everything is calculated. So first thing first, what we need to do, we need to create a histogram of words. Histogram as in a dictionary of words containing the frequency. So if you remember the bag of words model, we did the same over there as well. So I have now created a frequency like mapping where I get, okay, play actually come 3 times. I mean, play is actually happening 3 times in the complete thing over here. Cricket appears 2 times. Football appears 1 time and tennis appears 1 time. Football appears 2 times and tennis appears 1 time. Yes. So we have actually created this like mapping of the words and their frequencies. And now let me apply the formula of TF, right? So TF is number of repetitions of a word in a sentence divided by total number of words in a sentence. So let's say I take the word I take the word play. So when I take the word play, let's say play in sentence 1 actually appears only 1 time. So repetition of play is only 1, right? Divided by total number of words in the sentence is 2. So it's 1 by 2. In sentence 1, play has a TF of 1 by 2. Then again, play football. So play appears only 1 time in this sentence and the total number of words is 2. So it's 1 by 2. And then again, play cricket, football, tennis. So play appear 1 over here, 1 time over here, and the total number of words in the sentence is 4. So it's actually 1 by 4. So the term frequency is 1 by 4. Imagine if you have a sentence like play football, play, like in sentence. So just imagine. So then play would have appeared 2 times and number of words would have been 3. So the term frequency would have been 2 by 3. All right. Similarly, we would actually calculate for cricket, football, and tennis as well. Cricket appears in sentence 1 for only 1 time. Total number of words is 2. So term frequency is 1 by 2. Similarly, over here, cricket does not appear. In sentence 2, cricket does not appear. So number of words like containing cricket or the number of repetitions of cricket is 0. Divided by 2 is basically 0. And similarly, again 1 by 4. So you can actually calculate for all of the words like play, comma cricket, comma football, comma tennis, and you could actually create this table. So I hope you have actually understood on how to create the TF table, term frequency table. Nothing, just calculate, just see the word from here, like create a word histogram and pick up a word and see how many times that particular word appears in a sentence, how many times it does get repeated in a sentence, and divided by the total number of words present in the sentence. So you would actually get something like this term frequency table. Now once term frequency table is done, we come back to we now go to the second term, which is the IDF, inverse document frequency. Inverse document frequency, so it's given by log of total number of sentences divided by number of sentences containing the word. So I know total number of sentences is 3, so it's always fixed in my case that total number of sentences is basically 3, and then number of sentences containing the word. So how many sentences contain the word play, how many sentences contains the word to contain the word football, how many sentences contain the word cricket, and how many sentences contains the word tennis. So I have created an IDF table as well. So if you see play, so play is actually appearing in all of the 3 sentences. So it's log 3 by 3, which is log 0, and as you know, log 0 is already 1, right? Similarly, cricket actually appears in sentence 1 and sentence 3. You could actually go back to the video and check. So it appears in sentence 1 and sentence 3. So it's always log 3 by 2, because the number of sentences I have 3, and then cricket appears in 2 sentences, so it's log 3 by 2, which is log 1.5. But actually, compute the value as well, what value do we get? I have not written the value over here, I mean not the numerical value over here. Similarly, football again would have inverse document of frequency of log 1.5, which is 3 by 2. But then if you consider of tennis, you would actually get something like log 3 by 1, which is log 3, because we have 3 sentences and tennis only appears in the third sentence. So we get something like log 3 by 1. Right. And now once we have calculated our once we have calculated our term frequency and inverse document frequency, we could actually multiply the term frequency and inverse document frequency, right? Let us multiply term frequency and inverse document frequency. So we have to get something like sentence 1, sentence 2, and sentence 3, because we are actually making the vectors, right? We are making the vectors. So vector for sentence 1, vector for sentence 2, and vector for sentence 3. And then we could have words like the 4 different words that we have already found using the histogram: play, cricket, football, and tennis. So for play, if you actually multiply, so this is 0, right? So play is actually 0 over here. Okay, so a fault over here, it should be log 3 by 3 is equals to log 1, which basically should be 0. I have made a mistake over here, please correct it on your end. It should be log 3 by 3 is log 1, and log 1 is basically 0. So please do correct it over here. It's a writing mistake from my end, don't get confused over here. Sentence 1 is basically if you consider play, so play has now a value of maybe I could edit it somewhere. Let me just edit it so that you don't get confused. I don't know if I could edit it or not. So let me just add a text. Maybe let me say this is log 1, which is actually equals to 0. Log 1 equals to 0, and as you can see, I've edited it over here. So yeah, it's actually log 1, which is basically 0, right? So it's 0 multiplied by something 0 multiplied by TF. So TF is 1 by 2 over here, so it's actually 0. And then if you see about cricket, right? If you see about cricket, so what happens in cricket is that it's actually basically something like log 3 by 2, right? IDF is log 3 by 2, and then in sentence 2, cricket is basically, in sentence 1, cricket is basically 1 by 2, right? Cricket has a term frequency of 1 by 2 multiplied by log 3 by 2 over here. So 1 by 2 for multiplied by log 3 by 2. Similarly, if you consider for football, so football does not appear in sentence 1. Football does not appear in sentence 1. So 0 multiplied by log 3 by 2, it's 0. Similarly, you could actually calculate for tennis itself, right? You could actually figure it yourself. Similarly, for sentence 2, if you consider play, so play has a IDF of 0. So 0 would be considered. And then cricket does not appear in sentence 2. So again 0. Football does appear. So it's 1 by 2, log 3 by 2, log 3 by 2 from over here. And football and sentence 2, it's 1 by 2. So 1 by 2 log 3 by 2, and similarly you could actually calculate for tennis. So you could actually fill up this complete sheet, right? Like TF multiplied by IDF. You could actually go back and check and fill it yourself. So this is how we actually get the vectors over here. So this is how we actually work with a term frequency slash inverse term frequency and inverse document frequency, which is also known as the TF-IDF approach. Fortunately for you, you don't have to do all of these mathematics yourself in the code. A very fortunate thing, because sklearn or scikit-learn, whatever you like to call it, already has a library implemented for you, or already has a function implemented for you, which is known as TF-IDF transformer and TF-IDF vectorizer, which will actually do the task for you. So we will actually see that in the code itself. Like we will code all of these things up. Like we will actually do something for bag of words model, which we actually do using count vectorization and then using TF-IDF approach. So good thing for you that you only need to know the mathematics and not know the implementation behind it. If you want, you could actually implement this in Python itself. Like you could actually make your own library. But since you already have like scikit-learn already available for you, like the function is already available in scikit-learn for you, you don't have to worry about it. So I will end this lecture over here, the lecture of TF-IDF, with the hope that you have understood the mathematics behind it and you have enjoyed it, and how we are actually doing the TF-IDF approach and how it actually helped it to convert a text into a vector format. So see you in the next one.